Chapter 6, Elementary Statistics, Section 6.1. You already have a copy of this documents or lecture notes. Now, in the beginning, I want to show you examples of two variables. One, they call it discrete, and the other one continuous. One of the main difference between these two is discrete is whole number and continuous can take decimals. Now, for the discrete variables, I show you the x and p of x probability distribution for discrete. And if you notice on this one, the value of x has to be the whole number. Like in this one, number of patients who walk into doctor's office on a particular day, what's the probability that nobody walk into the office is that, and what's the probability of one person? So in case of discrete, you always come up with histogram or the bar graph. And then we understand that the probability is always positive between 1 and 0. It cannot go beyond 1 or it cannot be negative. And sum always has to be, sum of the probability always has to be 1. Now, if the variable is continuous, then, which is in chapter 6, then we are dealing with decimal numbers here. Like in this case, we are talking about the temperature. So since you have so many numbers between 0 and 1, it could be 0.1, it could be even 0.11, 0.12, 0.13. There are so many points. So in that case, when you graph or when you plot all the points and you connect, you come up with a curve. And so on this one, you do have a little bar graph, but do the calculation of the area is not that easy. Like here, for instance, if I want to know what's the probability of x less than 2, probability of x less than 2, all I need to do is just add area of these three rectangles, which is just the width times the length. But here in continuous, if you want to calculate, let's say you want to calculate probability of x is less than 0.3. See, in that case, you gotta find the area of this piece here. That is not as easy as calculation of the rectangle. Yeah, because a piece of this area is a curve. And based on that, we came up with several tables. And those tables are designed for continuous variables. You know, these are table A2. We have for the negative, we have for the positive. I'll go over these tables later on, but I want you to understand that these are all just for, these tables are for continuous variable, not for discrete. All right. We also have uniform. So if the probability, this is a special case of discrete. See how on the discrete you have different probability. Assume that the probability remain the same. Like when you roll a die 6 times, what's the probability of getting number 1? There are 6 numbers, 1 through 6 on the dice. So what's the probability of getting number 1? 1 over 6. What's the probability of when you roll a die is getting 2? 1 over 6. So they all have the same chances or the same probability. In that case, your graph, the y-axis remain the same because this is a probability. The vertical axis is a probability. So that would be uniform distributions. So this is a special case of discrete. So here we are talking about the normal distributions. Normal distributions, it's the curve is a bell-shaped curve. We see that on the next pages too. There is a special curve that has a standard deviation always 1 and the mean is 0. This type of curve that table A2 is based on, they call it standard normal distribution. So this table A2, see at the top, standard normal distributions, cumulative area, is a special case of bell-shaped curve, which has mean is always 0 in the center and a standard deviation 1. Horizontal axis, we call it Z, and the numbers are 1, 2, 3, -1, -2, -3. When you go beyond 3 or -3, the graph almost touched the horizontal axis. You know, curve is, so if you have all this bar graph, if you connect the top of all this, you see the bell-shaped curve. So this kind of a standard curve is a bell shape and is a symmetric, means, first of all, the total area under the curve is always 1 or 100%. So if they ask you what is the area of the half of this curve, is 0.5 or 50%. Now, here is an example of if you have a uniform distribution, how would you calculate the area? Like in these problems, it said it's a uniform distribution and horizontal axis is the waiting time and probability is the vertical line. So question is, what's the probability of waiting time of at least 2? At least 2 means greater than 2. So what they're asking us to calculate this area, which is very easy to do because it's a rectangle. So from here to here is what? Is a 1, 2, 3 units, and the weight is 0.2 given the problems. So when you calculate that, that would give you the probability. Probability is always this shaded area or what you have under the curve. For instance, if you have a histogram and I ask you to find a probability of, I don't know, X is less than 4, which this is 4, means find this area. There's always area under, in this case, it's not a curve. So this is this area. You have to find this area. Or here, if I say find probability of Z less than 2, means find this area. This is the probability. The probability under the curve, under all these histograms, is the area. So if you have a uniform distributions and they ask you to find probability of X less than or equal to 2, it would be just this one. Okay. And this is another example for you to see. So these two columns are given. And here we are asking you to find a probability of X greater than 2. So probability of X greater than 2 is area of these two rectangles, which I show you here. So area is height multiplied by width. Now, this is an example of continuous that we want to find probability of Z less than 1.27. So a standard curve, remember a standard curve has mean of 0 and a standard deviation of 1. There's a special case that standard deviation is 1 and its mean is 0. In that case, this standard curve, the horizontal axis, we are using letter of Z. Now, question is this. Find probability of Z less than 1.27. How would I find the probability of Z less than that? Okay, so what you do is you take the first digit before and after the decimal. Before and after the decimal, in this case is 1.2. You find that when you go to table A2, you find that on the first column here. The second digit after the decimal, which is 0.07, you find that at the top. And when you cross these two, this gives you the probability. For instance, let's look at this one. I want to find probability of Z less than 1.15. A standard curve, the mean is always 0, which is in the center here. 1.15 is somewhere here. Find the probability, the table A2. Table A2 always give you the area of the curve from that point to the left. It give you this area, and that is your probability. So on table A2, this 1.15, you write it as 1.1. The decimal, one digit before and one digit after the decimal, you find that one here. And the second digits, which is 5, you find that at the top. You bring these two, that give you the probability. So it's like here in this table. See how you have the Z here? You find 1.1 and you find 0.07 from here. And you bring these two. It's 0.8790. I'm sorry, this is 5. Okay, sorry. 5 is 1.1 and 5 is 0.8749. Okay. Now, so the standard curve, the middle one is the 0, and then numbers 1, 2. So when you get beyond 3, the graph almost touching. So not much of 0 is left here. When you go to the left, numbers is -1, -2, -3. Okay. So if I want to find probability of Z less than, let's say, minus 2.3. 2.3 somewhere here. And Z is this. This is the area. So now you go to the negative Z table, you find minus 2.3. And since the second digit is 0, you find the Z. That gives you the number. We also have a negative Z table too when you are dealing with a negative. See, these are negative Z table. So for minus 2.3, and the top is 0, is 0.017. Something like that. half of the area is always 0.50. So let's say we want to find probability of Z greater than 1.27, right? Let's look at this one. Let me show you different pages. So you go to the table and you find your 1.2 here and 0.07 there. Point 8980. Remember, table always give you the area to the left. See, you see the pictures? Always give you the area to the left. So this 0.890 is here. But the question and the problem is, what's the area to the right? What is this area? The total area under the curve is always 1. All I need to do is subtract this from 1. Okay? All right. And these are some examples here. See, now I'll also show you, if you do not want to use the table, well, of course, it's easier to use the calculator, right? So for these problems, probability of Z less than 2.08, if you use the table A2, then 2.0 from here and 0.08 from the top, this is the area, 0.9812. Okay, that's this area. Now, if you want to use the calculator always asks for boundary, like calculator always do this kind of calculations. It can always calculate, you know, there is a stripe here. It always wants Z1 and Z2. You need to calculate the stripe. But this one, we know this side, this one is 2.08. So we have Z2, but we don't have Z1. But remember, I mentioned that for a standard curve, when you go beyond -3, the graph is almost touching the horizontal axis, okay? So what you could do, you could take an arbitrary numbers, like -10, -5, -6, -10, and put that here. So calculator understand that it needs to calculate the area from 2.08 all the way to -10, because here is, you see there is no area left here. And that's how to do it. Well, the good thing is, when you use the calculator, if you don't use the calculator and you want to use the table, table always give you the area to the left, and then you have to subtract from that from 1, okay? Because what is this 0.9812? That is this area. But the problem is asking you to find this area here. So you have to, you go through the table A2. Table A2 give you the area to the left, which is 0.9812, and then you have to subtract that from the whole thing to find the area of the crosshatch here. But if you want to use the calculator for this, calculator require 2 boundary. One is 2.8. What about here? They give a positive 10 to calculator. So it would be normal CDF, and then would be 2.08 comma 10. Normal CDF 2.08 10. This is another examples. See, in this one, it show you, if you want to find the Z between these two, it's really a good idea to use a calculator. Otherwise, if you want to use the table, you got to find everything to the left for this, everything to the left for that, and then subtract. You got to do all this calculation. But rather than that, since calculator just need the boundary of the strip here, then you could just put these two numbers and find answers. Look in this one. We want to find the area greater than minus 1.75. Calculator need 2 boundaries. You have this. What's the other one? Give it 10. It's an arbitrary number. And then it does it for you. Now, these 3 examples are here. Sometimes in the problems, you have the area, okay? And you want to find the Z value. You want to do it backward. Like in this example here, find percentile of 99 or 99. That means, what is the Z value when the area is 0.99? Means probability of what Z is 0.99. See, completely opposite of that one. Z is in the questions. Area is a given. It's like, you know, here, these are all areas. What if I tell you, what's the probability when area is 0.8944? When it's 0.8944, you gotta go this way and that way and find your Z value. You do it backward. Okay, look, let's say they give you the area or probability, and we want you to find the Z. You go this way, is Z is 1.2, and then you move up. The second digit is 0.45. That's how you find it. Now, you could use the calculator. A calculator would do it for you. If you give an area to the calculator would give you the Z. Okay? How would we do that? I'll show you right there. Second inverse norm, give the calculator 0.99, it would give you the Z value. What is 10 percentile? What is P10? Means area is 0.10. What is the Z value? Has to be negative, right? Because it's on this side of that. Or, this is another problem, 39. They are telling you there are two tails. There are two shaded area. Both are 2%. Find the Z1 and Z2. Remember, the tail area are always equal. They both have the same area. The only difference is one is negative, one is positive. So if you calculate one, you don't need to calculate the other one because it's almost the same one. It's just with the opposite sign. Okay? So you go and say, second inverse inverse, no, 0.02. When you find it, this is the one on the left, right? The one on the right is a positive one. All right. So that end up 6.1.